We're here to speak to Dr. Bertram about his research regarding ice nucleating particles, and we prepared a list of questions to gain a little more insight about the relevance of the research. So we'll have Joy start you off with the first question.
What is the importance of your research of the ice nucleation?
Every ice cloud starts with a seed, and these seeds are ice nuclei, and they're actually particles that we're putting into the atmosphere. So you can imagine before humans come along, we have a certain amount of these seeds in the atmosphere, and they're making a certain amount of ice clouds. And these ice clouds precipitate out, so they would cause maybe a change in the hydrological cycle. And these ice clouds also reflect light back into outer space, so they can cool the Earth's atmospheric system. You can imagine humans come along, put more seeds into the atmosphere, that leads to more ice clouds, and then we have more cooling of the Earth's atmospheric system and more precipitation, for example. So if we want to understand and predict all of that, we need to understand what particles are acting as seeds and why they're acting as seeds, and do we have a good molecular picture of why they're acting as seeds. And so all of our work is trying to figure out what are the particles that are acting as these seeds and why they act as seeds.
What are some of the ice nucleating particles that you have come across?
So one is dust. Another type is biological particles, so things like fungal spores and bacteria. We're trying to understand if they cause or act as seeds for ice clouds. And then another one is black carbon, so soot from your car. So every time you drive your car, are you putting more of these seeds into the atmosphere and causing more ice clouds?
Do we know about how many of these seeds there could possibly be in the atmosphere? Or does your research group explore that at all?
So part of my group is more fundamental. Things that we do with Kaitlin is trying to understand why things act as seeds and try to understand the mechanisms. The other part we do is field measurements. So we're actually going to the Arctic and making measurements up there and actually measuring concentrations of these seeds in the atmosphere and trying to understand which ones are causing ice nucleation.
What is the importance of studying the size of ice nucleating particles?
Yeah, so we study size, partly because that gives us hints on what types of particles could be acting as these seeds. So we know that mineral dust and biological particles are very large. They're what we call supermicron, above 1 micron in size, whereas black carbon or submicron, they're very small. So if we knew the size of these particles that are acting as seeds, that might give us hints in which direction or which types of particles are important. And so we've gone to 6 sites now in North America and 1 in Europe, including a place in the Arctic, one at the top of Whistler Mountain, and several other places around North America. And in all the places we've looked, the particles are big, so they're in the supermicron mode, which suggests they're likely mineral dust or biological particles.
After speaking to Dr. Bertram about the importance of his research, we later caught up with Kaitlin to ask about her findings from the research.
Now that you've completed your research, what can you tell us about ice nucleating particles?
So I think what we can say in terms of ice nucleation and the effect of salts in the heterogeneous ice nucleation process on silica surfaces is that it's very important to know the composition of the salts because the cation, the type of cation, like the nature of the cation, has a large effect on the water structure, which is going to mean that it has a large effect on ice nucleation.